Good evening. My name is Usman Shakeel. I'm a solutions architect lead for media entertainment at Amazon Web Services. So recently, we've been hearing a lot from our customers about the 4K media workflows, and the challenges that they bring about in terms of the size of the storage, the bandwidth requirements, the network requirements, processing requirements, etc. And how can AWS help? How can the feature set and the services that we provide help in terms of overcoming those challenges? And that's really the topic of my talk today. Okay, so most of us already know the concept of content gravity. Michelle did a great job earlier before me from Spara talking about transferring video and live video over distances, right? So basically, what we see is that just like data gravity, the concept of data gravity, content files being very large in terms of the size also tend to have the content gravity. So basically, anytime you're going to want to process the content, processing is going to be easy, whereas the biggest challenge is going to be moving, transferring the content from one place to another. Just from the context of 4K, doing a quick comparison, 4K files at a ProRes 4444 is over a terabyte for a 60-minute show, for example. Whereas if you compare it to an HD at 422 HQ high quality, it's somewhere around 80 gigs. So there is about a 10x difference in terms of the size, if you will, and so that's going to translate into in terms of what is going to be my near-term storage and what's going to happen to my archive storage. How am I going to be able to store it? What is going to be the appropriate mechanism? And it also, in terms of the resolution, if you look at it, there is 4x the number of pixels of today's HDTV, if you will. So with the content gravity, there is also the issue of the bandwidth. So the bigger the file size is at the end of the day for the content, the harder it's going to be to transfer the content over to the partners or any other vendors that are going to be providing services on top of that content. So that leads to a big challenge in terms of affiliate transfer or affiliate delivery. Anytime you're going to transfer that content over. And there are also challenges around consumer delivery. So, the bottom table here talks about 1080p versus 4K and the different formats. So, as we can see that compared to the size, the consumer delivery piece of it is actually not that bad, thanks to some of the improvements in terms of the encoding and the compressions, from HVEC, VP9, etc. But still, there are a lot of questions in terms of how the networks are going to be able to handle the peak usage of 4K streaming. And it's not just in terms of the content gravity is not just in terms of, say, storage and bandwidth only. The processing piece is also going to be pretty tough. So if you look at some of the formats that I talked about, the HVEC or VP9, they require a lot more processing cores. So at the end of the day, you're going to hit that physical limits of an individual server, like how much total content, how many content files are you going to have per server in order to transcode, encode, package, etc. So at the end of the day, you have to look at distributing your processes or workloads. So where really is the problem? This is just a quick graphic of your media workflow, starting from ingest to the process, store, and then finally delivery. So as I talked about, the problem of delivering the content to the consumers is getting better. Thanks to adaptive bitrate, HVEC, etc. It's getting better. It's not as bad in terms of compared to storage. Whereas storage is really going to be the key problem where, first of all, you're going to run into storage capacity. There's going to be issues around bandwidth. There's going to be issues around the compute. And that really translates to a lot of cost. It's going to be harder, more expensive to do that. But at the end of the day, question is, does it really matter? How much of a screen size are you going to really need to see that this 4K type of content or appreciate it? I myself being in the trying to buy a big screen TV, and I tend to do some research on it, and really my conclusion was that at the end of the day, unless if I want to go say bigger than a 60-inch TV, probably and also look at the my living room space, how far or what kind of a viewing distance I'm going to have, it's really not worth from a consumption perspective. Whereas what we see is that these TVs are still in production. Obviously more and more newer formats, more and more newer technologies, cutting edge technologies coming out, but still there are a limited number of say handheld devices or small devices at the end of the day that are going to be able to accommodate 4K. But it's getting better at the end of the day, and there are some technology challenges as well. And there is obviously more. We already saw the 8K and better resolutions last NAB, and I'm sure there is going to be way more this year. And what we see the trend kind of is that the content producers at the end of the day are moving towards 4K and ultra high def type of content from the consumption perspective. So at the end of the day, if I'm a content producer and I have these media production workflows, I can, go with the flow, upgrade my hardware, my licensing, my software, my storage, all to accommodate the 4K. Or I can say that I don't really need it because you know what, it doesn't really matter for some of the majority of the consumers. Or I can wait for the next 8K or who knows whatever next, right? And but the idea being, where is this sliding scale for the infrastructure? And that's really where the cloud comes into play. So I tend to work with some of the big data challenges as well, and this is one of the pretty cool concepts that I learned there. The idea of data lake. So what they talk about is that you basically keep dumping all the data into one big storage. Doesn't matter how you normalize it, or you don't even have to normalize it. Whatever the source of that data be, can we apply the same concept to content and call it a content lake? So basically, the idea here would be that you keep dumping all your content, whatever production it is, whatever resolution, whatever format, into a storage that is highly scalable, and really leave the processing nodes or the consumers applications to use the scalable infrastructure with it. So if we do this, the content lake is going to have some requirements. First of all, it has to be durable, and it has to have pretty much infinite, unlimited type of storage capacity, and the also the requirement of very very large file sizes has to be very highly scalable, highly available, and also being able to be usable with many different applications. So if we look at Amazon S3, the simple storage service, it's actually our object store. Basically, it gives you a very cost-effective, highly durable, and fast way to store your objects. There is really no limits in terms of the total amount of content or data or files that you can store inside of S3. It's highly scalable front end. Basically gives you a very highly scalable front end that allows you to do multi-part uploads or range gets. So that means that you can really distribute your applications in the true sense. And you can also use S3 with on-premise storage, if you will. So we'll talk about some of the partner solutions and some of the architecture patterns in this space. But the idea is that this could be your big content lake where you are storing all your content for durability, cost effectiveness, and ease of use. And then finally, it is secure. So great, I have this great solution in terms of storage where it's cost effective, it's highly durable, it's all good. What about hydrating it? Right. So I have a lot of content on premise, or say I am creating content, producing content. I need to move it over to S3. So as I talked about earlier, S3 provides you a pretty highly scalable or massively scalable front end, and with so you can basically what that means is that you can use your network bandwidth. You can literally just saturate your network bandwidth, all that is available to you, distributing your uploads or ingest into S3. You can use your S3 multi-part upload, which is a part of the SDK, to build a highly distributed system that ingests at high scale over to S3. You can use some of the partner solutions like Aspera, Signia, and Attunity. There are a bunch of them. And also, depending on the use case, if it is, say, something like a live or near live type of a use case where you want very high sort of performance, you use one type of a solution. If it is more like a file-based or a back-end sort of say appliance-based type of solution, there are a bunch of partner solutions in that arena as well. And AWS itself also provides the Amazon AWS Storage Gateway, which is an appliance that you store on-premise, and it automatically keeps on syncing your content with S3. You can also use import-export, which is literally, as it means, that you ship us the drives, and we ingest your content, put it into S3. The most of all is the idea is that really the scalability concept, right? That you can saturate whatever network is available to you. And there is also a service called Amazon Direct Connect, which allows you to peer with us over multiple 1 gigs or 10 gigs direct connects. So what that means is that then you can have a private line into Amazon Cloud and push all the content. Depending on how much content you have, you can really scale that as well with pay-as-you-go type of pricing without any lock-ins. You can have one 1 gig or 10 gig line, or you can have multiples of them, really depending on the amount of content that you have. So at the end of the day, you get a scalable way of hydrating your content lake. S3, when you create an S3 bucket or you're putting some content in S3, it is specific to a region. Any of the services that we provide, any of the resources within AWS that you create are regional specific entities. What that means is that all the durability that S3 provides, the 11 nines of durability, the very high availability that S3 provides, all the different feature set that S3 provides, it is all within one single region. That meaning within a region, we have a concept of availability zones, which are separate physical data centers, if you will. And once you upload a copy of a content, once you upload a piece of content in S3, we are making multiple copies and storing those copies in these data center clusters, if you will, and providing you the type of durability and availability that you're looking for while staying within that region. So there are, some cool benefits there from a privacy security perspective. Say you have some content that is say specific to the USA, cannot be shared outside of US. Well, in that case, you have it in the S3 bucket within US. It's going to stay in the US. Some content which is specific to South Americas, you put it in a bucket in South America. It's going to stay in South America. Now, so that's so much for content proximity or wherever your content is physically located. In terms of, we also have customers that have their workforce geographically dispersed. What happens in that case? Now, S3 also provides you a feature that allows you to copy your content from one S3 bucket to another S3 bucket. But you have to explicitly start that or start the process. The benefit there is, well, first of all, locations at the end of the day, right? That you can share the content that way if your workforce or your partners are geographically widespread. And also, in many cases, specifically within the US, when you are copying content from one region to another region, it is actually traveling over Amazon's powerful network backbone. So that's a pretty big, feature or powerful feature that you can use. That also gives you very cost-effective means to do that. So basically, you're not using your network bandwidth; rather, you're using Amazon's network pipe to transfer the content around. So again, the scale of the cloud comes to the benefit of, comes to your benefit when you have to transfer or share very large files, when you have to ingest very large files across the globe into the cloud. So that's the idea at the end of the day. So from regional lakes to, let's talk about some of the cost-effective features or content lifecycle. So Amazon S3, we talked about in depth, what kind of durability, what kind of availability, and cost effectiveness it provides. There is also another service called Amazon Glacier or archival service that we offer. Now, both of these services are very nicely integrated with each other. In a sense, you can think of it as different storage tiers. So S3 gives you very high, scalable, highly available front end, meaning that you can have a few threads to several million threads requesting S3, and S3 will scale automatically and basically serve all your requests. It's all a synchronous model of retrieval in the case of S3. Now, as I mentioned, the Glacier service or archival service, it's tied very neatly with S3, where you can define policies. Policies like I want my content, which is 3 months old, a month old, whatever that you choose. After that timeline hits, that content trickles down to Glacier, which is our archival service. Again, you get the same level of durability, but it's much cheaper. The only caveat is it's asynchronous retrieval, meaning it's not accessible to you right away because it's archived. The benefit, another key benefit there is that it is one single API. So from your application perspective, they're all interfacing with a single API. So your application doesn't need to know which tier storage your content lives. It just goes and requests that content, and S3 front end returns it. Okay, so we talked about storing, ingesting. How about consumption, consuming the content lake? So content is there. How do we make powerful applications out of it? So first of all, a lot of people say, okay, it's object store. There isn't a quick or fast access to it. How am I going to be able to build an application which is highly distributed application and scalable? Taking the same analogy as ingesting or hydrating the content lake, we're using the same for consuming from the content lake. Again, if it is on premise that you need your content, you build multiple direct connects, or you can use your normal internet, and really saturate the network that is available to you by using things like S3 range gets, distributing your application, using Spera, Signian, etc. Or if you have applications that are running on EC2, talk about compute in a little bit here. Basically, there are things like a Vir FXT or VFXT, which can be used as a storage cache. So you are accessing it as a file system, and a Vir will bring it or fetch the content from S3 and cache it. Same, Intel Luster is another very powerful one, which is a shared file system. The new version actually now allows you to build a highly scalable automated shared file system, which you can specify or point to an S3 bucket, and it will prefetch the directory tree for you. So very powerful use case there as well. So the trend or the sort of pattern that we see at the end of the day from an architectural perspective is a storage cache that your applications are accessing while accessing content from S3. So this massively scalable compute layer, what can you do with it? An important thing to also keep in mind is that it's not just one type of compute. You get in EC2 instances that have different characteristics from a pure CPU memory perspective, but also from an I/O or a storage perspective, or things like even GPU instances, right? So in this case, as I am pointing out here, basically from your content lake, you have access to the content. If you want to do, say, simple HD encode, if you want to do some kind of GPU transcoding, you can use the GPU instances. For HVEC encode that require very high CPU capacity or a lot of cores, specifically in this case, our C4 instance types that have the ES2664 CPUs or cores in them that are, say, optimized for EC2 specifically, to our I2 instances, which are high I/O instance types based on SSDs. So really, at the end of the day, you can select an instance type which is specific to your workload, and you don't have to stick with, say, a physical hardware which is going to be there for the life of it, and you're basically just stuck with it. From a cost perspective, there are a number of options. So my favorite one, spot instances. I say it's spot instances because, a lot of these production, post-production workflows are batch type of workflows anyways, right? So, like transcode, encode, package, everything is a batch workload, and Spot instances is a best, I would say, feature from a cost perspective for that. So, Spot, for those who don't know, is actually our excess capacity that we allow our customers to come in and bid. It's better, always better, if the your running server is in use rather than having it running for no reason. So just a quick example here. A couple days ago, I just ran a report. This is an ongoing price for the Spot instances, and I ran a report on our R3 8 extra large, which is our largest high memory instance type. The running price per hour is $2.80 in US East region, whereas on Spot market you can get the same instance for 35 cents. It's a big number difference in terms of cost. So how can I use it? Right? Really, it's very simple. At the end of the day, Spot can be used in a number of different ways in your auto scaling, in all the different applications that you build. Really, the key thing is that how can you decouple? How can you decouple your application from storage? A lot of these processing, a lot of these compute applications are either small, or if they can read and write back to the content lake, then you're decoupling that storage, and in that way you can use the cost benefits as well. Then there is a misnomer that really, I mean, the Spot instances are going to be taken away from me if people outbid me. Sure, it is. I mean, hence that's why you're getting this price. But first of all, there is no charge if the Spot instance is terminated away from you. So let's say you run a Spot instance, you used it for 50 minutes, and then it's taken away. You won't be charged for that hour. In reality, I have customers, very large studios running their even visual effects studios running their visual effects pipelines, rendering pipelines, purely using Spot. What they have is a simple model. They have a lot of Spot instances up and running all the time, and if some of them are taken away or terminated, they put more in there, right? If I look at it in reality, well, there is no guarantee that when a Spot instance is going to be taken away, but really, what I've seen in reality is it's not that often. So it's all about supply and demand at the end of the day. Then there's reserved instances where you can buy the capacity upfront, pay for it upfront, and then you get discounts. But the idea here is that it's really the pay as you go model, and it's really short term versus long term. So if you buy what you need, if it's a short term or a very quick running job, then what type of compute you're going to buy. If it's a long running job, then what kind of compute you're going to buy. If it's a real time process versus a batch process, can you decouple storage or not? So there are a lot of architectural patterns that you can really build with this kind of a model compared to what you have, say, in a physical environment. And then finally, the AWS marketplace, where now software tool set that you have, you don't have to go buy licenses for that. It's expensive. Really buy stuff which is hourly licensing, or bring your own licensing model. So all that stuff is available to you from AWS Marketplace. This is a very interesting concept. Basically, the idea that your infrastructure doesn't have to live forever. It lives there only for the time of the project. Just imagine, you've got so many titles in your content library, so many very large files. You don't know when a new device is going to come into the picture. When do you have to go transcode your entire library again? Or let's say not entire library, maybe a few titles here and there. So what are you going to do? Are you going to have, these fleets of servers running all the time? Or can you just simply spin up a transcoding farm very, very quickly with a simple click of a button? Basically, Amazon Machine Images, Amazon CloudFormation give you the capability to really automate it, templatize your entire cloud infrastructure. That could be one node to hundreds of thousands of nodes, really, that can be auto-scaled based on the need of a particular project at hand. And once you're done with all this, you just simply call the CloudFormation terminate stack, and it's all gone. You're not paying for anything. Your stuff that you did is stored inside your content lake for the durable storage, and your processing, your infrastructure around it was really scalable and agile. Very quickly, the AWS ecosystem, as you can see, a lot of different partners in so many different workflow tasks, areas of workflow, sub workflows within the media workflow, from ingest, store, process, manage, deliver, monetize, security, all sorts of things, right? A lot of them also available as the cloud friendly hourly licensing model. So AWS Marketplace is actually a storefront where you can go and launch an EC2 instance with the software included, pricing in it. So a great thing that customers get a lot of value out of. So how about affiliate delivery? So we talked about it as one of the challenges. That with the increased bandwidth requirements, how are you going to be able to deliver that? And a lot of our customers actually a customer started asking us, so we do this traditional sort of say satellite delivery. Can you guys do anything in that case? So we started thinking about it, and actually I'm giving a session tomorrow on this particular title. So if you guys are interested, feel free to take a look. The session title is "Shoot the Bird: Linear Broadcast Distribution Powered by AWS." So this is your traditional multi-hop satellite distribution model, where you have your field source encoder on one end. The first hop, it's going over the satellite, going into a head end or processing nodes. That's where you're doing a bunch of encoding, transcoding, etc. A lot of stuff happens, and then through the second hop, it goes to the affiliate. That the affiliate then does decoding. So how do you do this on AWS? We actually did run a POC with a few customers, some great performance numbers that we found. So here it is. Basically, you have your field source encoder. You can use the internet or the cellular networks to go on straight to AWS. Or let's say we keep the first hop as is. On the second hop, basically from the head end, you can have a direct connect pointing into AWS. And what you're really doing is you can scale out the ingest. So think of it as each EC2 instance being an ingest endpoint or node, and then you can scale as many of them. So at the end of the day, you need bandwidth. You can have you scale out your ingest layer or tier. That's the bandwidth you have. And then you fan out and then you egress. So basically all EC2 instances running there and scaling out. And then from there on, you can egress or deliver it to your affiliates that are say using it. So going a little bit deeper into this, on one end is your encoder, and you're using Amazon Direct Connect. The ingest piece itself could be running on, say, your standard EC2 instances, like M3 nodes, we call them. And you can scale based on however much you need in terms of bandwidth, right? That's the beauty of it. And then let's say you're doing some kind of a GPU transcode on it. You can use the G2 instances. And then you want to egress. For egress, you're again going to need a lot of network capacity to egress out to your broadcasters. And that's where you can use our C4 instances, our high performance type of instances. But in this case, it's not just affiliate delivery. I guess the main point here is this piece in the middle, the content lake, right? That you're not just delivering the content to the affiliates, you can also store it, record it, store it inside of your content lake, which opens up a whole lot more set of avenues for you, where you can then do HLS and then deliver HLS direct to say your low bitrate proxy, for example. You can store it for other usages, archive, etc. So that's the whole idea. Yeah. So some of the some cutting edge stuff we talked about. There is a couple of more things that I want to quickly talk about that are my favorite, in my opinion. I really like them because they're brand new services that we launched and pretty applicable here as well, I thought. So first of all, let's take a simple DAM, digital asset management system on AWS. Very simple. You have an ingest coming in, stored into S3. While it's stored into S3, we launch S3 notifications. So what that means is that anytime an object or a file lands into S3, it will trigger a notification for you. The S3 notification then can be used to populate the queue using the Amazon Simple Queue service. From there, the queues can then launch the metadata workers or your rendition workers that can launch Elastic Transcoder, which is our managed transcoding service, a transcoding job, and the output is stored in S3. Or the metadata workers can extract out metadata, store in DynamoDB, which is our highly scalable, durable NoSQL service. And then your cloud search, which is again an Amazon search service, feeds through it. And then you can build a front end for your DAM or deliver the proxies through CloudFront. So very simple, at least on the slide it looks like. And you can actually build it. We have CloudFormation templates that allow you to build these stacks, these individual tiers very quickly. So from a cost perspective, depending on how many servers are you going to be running, to do each one of these jobs, metadata workers, your rendition workers that are going to be spinning up those jobs, it tends to be, it's not that expensive, but at the end of the day, let's say if it is, and really depending on the scale of it, let's say if it is a few hundred EC2 instances that you're running, hourly cost for those or reserved instances cost for those, we're talking about, a few hundred to maybe a few $1,000s. Now, we talked about spot instances, using spot instances for that. Obviously, you can use it because it's all a bashed environment. So here, the price comes down pretty quickly, right, in terms of the hourly pricing. And here, we're just talking about purely compute pricing. Then there is AWS Lambda. That's a brand new service we just launched, right? So what is Lambda? And what does this really give you? Basically, AWS Lambda is a way for you to define a function, upload it into the cloud, and have a notification just simply go trigger it without any servers, without any instances running, or without any infrastructure, I should say, running to create that or to manage that function. So in this particular case here, the simple DAM, it is really simple, right? There is no servers involved in this entire DAM. For your metadata extraction, for your proxy creation, anything. It's all a set of managed services from AWS and does not require you to build a single, even EC2 instance or a virtual server. So great. And from a pricing perspective, it drops it down even further. Great. So one other one, which is, we often see in our media workflows, so yeah, I could do all these batched type of jobs in the back end on the server side. I can have a fleet of transcoders running, fleet of renders, engines running, a render farm running, and doing all those kind of crazy things, right? But what about interactive type of applications, things that require thick clients? I want to run Avid. I want to run Autodesk Maya or Adobe suite of services, etc. I want to create some visual effects or post-production type of capabilities. Well, my content is in the content lake, right? That's in the cloud. My graphic artist or somebody, they're sitting geographically somewhere else, who knows where, right? So at the end of the day, the content gravity concept comes into play. How do I manage that? So we talked about the EC2 G2 instances or GPU-based instances. We have a service called Amazon AppStream, which kind of gives you this capability to remote stream these applications. So the idea is that you are running your G2 instance, which has access to the content in S3, right? And then you are running your Avid or Autodesk Maya on a G2 instance, and you are streaming the whole application experience to a dumb client. That could be a tablet, that could be a laptop, whatever have you. But at the end of the day, you don't require A, the movement of the content all the way, and B, you don't require any beefy workstations for your graphic artist or your talent. So AppStream is our service. We have a few partner solutions. One applicable one here is the Tardy GPC over IP. It's available in AWS Marketplace as well. Again, something that some of my customers, specifically in visual effects shops or rendering, are using. So very excited about this service as well. And one of the key features or benefits here also is that your talent or your graphic artist or your workforce can be anywhere in the world, and you don't have to move your content. So that's highly secure. You're basically just giving them access or streaming the underlying application to them. So, in summary, very quickly, we talked about the concept of content lake and how it can help on AWS side, right? So, the idea that it has to be really boundless in terms of the amount of storage, has to be very highly available, durable, and cost effective, and readily accessible to all these different tasks within my media workflow. And that's where Amazon S3 comes to the picture. It's highly scalable. You can archive things with Glacier, nice integration there, integration with CloudFront, or you can use with any other CDN for delivery. If it is affiliate transfer, doesn't really have to be affiliate transfer. It's actually giving access to the content to others. And the disposable infrastructure concept that we talked about, it's really that your infrastructure doesn't have to live there. You don't have to go manage it. It's really there for the scope of the project. Your VFX or other production tools, we talked about. So at the end of the day, if your content lives in a highly durable and scalable environment, there are a lot of avenues that you can offer to your content from processing perspective to a bunch of others. Thank you very much for the time. We will be at the NAB show. Please come by and visit us. There will be a presentation theater. Where we'll be giving a lot of AWS presentations. We'll talk architecture. You can meet the AWS experts. We'll have our partners at the booth as well. And if you are interested in, in general, AWS media entertainment workflows, that's the URL up there that you should go check out. Thanks.